For Achieve Homework 4. The first question is asking you to select which of the particular vibrations, so it's referring to the carbon-carbon double bond or the carbon-chlorine single bond, which vibrations should be IR active. Remember, in order to be IR active, a bond needs to be completely asymmetrical on either side of the bond. So I think that the best option for you with these different molecules is going to be to draw them out using a line structure or a condensed structure, and then analyze the particular bond that it's asking you to analyze, and just have a look at either side of the bond. So the carbon half of the bond versus the chlorine half of the bond. If both halves of the bond are exactly the same, then the bond is inactive. If the two halves of either side of the bond are not exactly the same, even if they just have one small difference, then the bond will be IR active. Question number 2 is asking you to sort these different wave numbers as belonging to either the functional group region or the fingerprint region. The fingerprint region is the area of an IR spectra that we don't analyze, the part that's on the very right-hand side. And in your notes, you have reference to exactly what the cutoff point is for the fingerprint region. Anything to the left of a particular spot is going to be the part that we do analyze, which is the functional group area, and anything to the right is going to be the part that we ignore or don't analyze, which is the fingerprint area. This one is giving you 2 molecules. They're both alkenes, and it's asking you, first of all, to identify which absorptions you expect to see in both. So what do they have in common? And then it's asking you to find the one peak that is going to be present in one hexene, but you're not going to be able to find it in the spectrum for cis 3 hexene. So I didn't mean to select that. I think that probably your best bet for this is going to be to look up what each one of these different wave numbers corresponds to, what bond they correspond to. And then it looks like the wave numbers for part A are the same as the wave numbers for part B. So you only need to look them up one time. And again, I really didn't mean to select that, but I can't unselect it. This one is asking you to rank these bonds. It's talking specifically about the carbon halogen bond, so the carbon bromine versus carbon iodine versus carbon chlorine, highest frequency versus lowest frequency. You're going to want to refer back to one of the early videos from Monday that talk about frequency and how that relates to energy or the strength of the bond, and how that relates to wave number and all of that type of stuff, and how it relates to the mass of the atoms in the bond. What type of information is given by IR spectroscopy? So for this, just look up the definition. What kind of information are we actually getting when we look at the IR peaks? Let me back up to that question again. Make sure, yeah. This one is telling you have a band, a peak. One of the things that's kind of weird about this is that we call them bands, we call them peaks. There's a lot of different names that we give to the peaks in a spectra. Medium intensity around 1641 or 1640 wave numbers. What is the bond that's responsible for that? So in that particular area, are we talking about a single bond? Are we talking about a double bond? Or are we talking about a triple bond? That's going to be, I think, the first way to start narrowing it down. Like, what type of bond are you going to see at 1640? And if it is a single bond, then you've got two different single bonds to choose from. Here is a spectrum, and it's just asking you to determine which one of these molecules matches up best with this spectrum. Now, just you want to take your strategy for analyzing. You don't want to look at the whole entire spectrum, which means we're not going to be looking at stuff that's over on the right-hand side. You're looking for key peaks, things that are the most important. Once you identify what type of functional group the peaks correspond to, so what type of functional group corresponds to this peak right here. If you decide that this peak right here corresponds to an ether, then what you want to do is go through these names. It looks like there's only one ether on the list. That must be what it is. And there you go. It's not an ether. And here's a pretty similar one. This one's actually really tricky. You've got, it's a funny looking spectrum because the scale is kind of stunted and it's a little different than normal, but there are not very many peaks in this spectrum. We have this pretty strong peak at 1710, and you need to figure out what that corresponds to. And you've got these 6 different molecules to choose from. You have alkenes. You have alkenes with aldehyde, you have ketone, you have alkene with ketone, you have plain aldehyde, and you have alkenes with ketone again. So you've got a few different choices here, but I think start by narrowing down what functional group is going to be present at 1710 and start eliminating the molecules that don't correspond with that. That should make this problem easier. Here's another one. What compound matches this spectrum? I kind of feel like it's the same list of molecules as the problem a couple problems ago. This one right here kind of looks like it's the same list. It's going to be easier to work on problems like this if you draw out the structure. Well, it might be easier if you draw the structures out for these 8 molecules or look them up just to kind of see what functional groups are present. And then again, remember, don't get distracted by the stuff on the right-hand side. Just focus on the left half of the spectrum. What does this peak correspond to? What does this peak correspond to? Those are your big hints. Here's another one. Again, looks like it's the same molecules, same choices down here, same strategy. Focus your eyes. Make sure you're not looking at things that you shouldn't be paying attention to. Draw that line at 1500, and that means you're going to be ignoring like half of what's present on this spectrum. There's not much information on this spectrum, which in itself is a hint. When you look at this and you're like, I don't see anything to analyze, that in itself is a really, again, I did not mean to click on that. That's a really big hint about like lack of functionality in a molecule. How can you distinguish one hexene from one hex sign? So here you just want to look up look up what you would see in an alkene versus what you would see in an alkyne. Keep in mind they're both terminal alkenes and terminal alkynes. You might have to use that to solve the problem. You might not, I don't know. Here's another one. Choose a compound that matches up with this spectrum. This one is giving you some pretty specific wave numbers to pay attention to, which may or may not be helpful. It might be drawing your attention to stuff that you actually want to ignore. So I would begin by looking up or drawing the structures for each of these molecules. Toluene and aniline are molecules that we haven't talked about yet, so you wouldn't know what they look like. You'll need to look them up and see what their spectra is. And then just start ruling out, like ethanol, that's an alcohol. And if you have an alcohol, you should see something like really specific that's, kind of indicating that there's an alcohol present. Same set of 4 molecules, and here's a different spectrum, same thing, you're just going to match it up. This one is it's giving you a little bit of a story up here, but you actually don't even need to really know the story. I mean, maybe kind of. It says you had a secondary alcohol and you oxidized it to a ketone. One of these spectra is for the alcohol, one of them is for the ketone, one of these spectra is for the alcohol. And so in this box, they're going to choose the compound. Here's your alcohol and here's your ketone. And then it's asking you to identify just 2 particular peaks, one in each spectrum. So what is the 3350 wave number correspond to? It's got a few choices. And then what is the 1680? Now I'm actually kind of confused because it says ketone and it says alcohol. Oh, dropped the name and classification. So it wants you to put the name of the alcohol and it wants you to indicate that it's an alcohol. Both of that goes into that box. Plus you have to identify what type, OH, carbon-carbon double bond, carbon-oxygen double bond, carbon-hydrogen, what type of peak is each one of these. This one is just asking you to identify the type of peak. There's two that you're choosing from here. What type of peak is it? Now we're moving on to mass spec. Which peak is the molecular ion? Molecular ion is the M+ peak. So it's giving you 6 choices there. This one is asking you which molecules will have an odd-numbered molecular ion peak, which will have an odd-numbered M+ peak. Look in your notes to see what causes a molecule to have an odd-numbered molecular ion. This one is asking you to choose the formula of the molecule that gives us this particular mass spec. 26 is the M+ peak. These guys have different molecular weights. Like, you don't have, this problem is a lot easier than it looks. Add up the molecular weight of these 4 molecules. Which one has a molecular weight of 26? There's your answer. This one, a little bit trickier. So this one is saying you have a molecule, a molecular weight of 27. That in itself is a big hint. That's an odd number, hint, hint. And then it wants you to draw the structure of a molecule. It says that it's neutral molecule. So that means it's not a cation, it's not an anion. That means that all of the atoms in this molecule need to have a good bonding environment. They need to have the correct number of bonds. That should help you draw that, plus the 27 should help you draw this structure out. And then the last one on here, which structure best fits the mass spec data? You have 4 different molecules. They have 4 different molecular weights. The easiest way to answer this question would be to add up the molecular weights of all 4 of these guys and compare that to the 7880 that you see in the provided mass spec.